I'm going to compare the behavior for first and second order reaction that initially have the same rate of reaction. And so I picked the conditions where the initial concentration in both cases is 10 moles per liter. And so the first order rate constant, and its units minutes to -1, whereas the second order rate constant, and keep in mind, second order rate constant has different units, so we can't compare the numerical values. So if I now calculate the initial rates just to show that they're the same. So you can see the initial rates are the same, but as reaction proceeds, the concentration of A for the first order reaction decreases faster. The rate that product is made in the first order reaction is higher, and so the concentration of B increases faster with time. And so second order reaction, as the reactant concentration decreases, then the rate is decreasing faster, and the end result when we compare the two is that after a given time we have a higher conversion, a higher concentration of product for the first order reaction. When we're comparing these two rates, the question is sometimes raised that when I have a concentration of 10 and squared and I square it, then that is a bigger number. But if the concentration, say our initial concentration was 1/10 of a mole per liter, then squaring that is a smaller number. How is that consistent with this behavior? If we wanted to compare, and we had a system where the initial concentration is 1/10 of a mole per liter, and again we'll have the initial rate be 1 mole per liter per minute, that means the K1 value is now 10 minutes to -1, and the K2 value is 10 squared liters per mole per minute. So keep in mind, K's have different units. I can't compare their numerical values, but if I use these conditions, I see the exact same behavior, only difference being that the concentration scale here goes from 0 to 0.1, but again, the first order reaction makes product at a faster rate. We have a higher conversion for a given time. Now these curves were generated just using polymath, so for those who are familiar with polymath, I've included the polymath program here that would calculate concentrations of A and B for first order and second order reaction as a function of time.